recording, it turns it green. And so the pound symbol is important for comments. Another useful thing is the question mark. And you search for function helps. If I want to see what filter does, and I press question mark and type filter, this is kind of where those conflicts also come into place, where now it knows, hey, like filters in 2 packages. Do you want to return rows with matching conditions, which is in dplyr, or do you want linear filtering on time series? So maybe I want the rows. Which now it says, hey, the function name is called filter. It's in dplyr. This is sort of how you use it. Details. It shows you some other examples. See also. Then it gives you example code that can run, that you can see sort of how the code works in practice. And so we'll cover some of these functions in a second. And so you've installed some packages, you've initiated them into your R session. And so now let's do some example exploration. For this, I'm just going to close my history. And so again, Control-Enter sends code to the console. And so one data set that gets loaded with ggplot is called MPG, or miles per gallon. So if I press Control-Enter, it sends the code over. And so this is a tibble here. And so it's a special type of data frame called that basically just limits how much data is displayed to you. And so it tells me there's 234 rows and 11 columns. It just shows you as much data that will fit on the screen. And so here it's just showing 10 rows in the first like 5 columns or 6 columns, but then saying, hey, there's 5 more columns: drive, city, highway, FL, and class. If my window is like way, way bigger and I try to print that tibble, it will show the whole thing. So it's sort of dependent on how wide your window is, which is maybe good or bad. But now it'll show you all 12 columns or 11 columns. And so you can also maybe just see the first 6 by default with just head. That's a little bit less useful for tibbles because it sort of already controls how many rows it prints. But now we're going to go into a little bit more detail for some of the plotting code we just showed in the lab. And so ggplot2 is called the grammar of graphics. Typically involves initiating a plot, sort of a canvas, then adding layers to it with this these different commands. And so this looks a little bit different than regular R code, where there's these sort of floating pluses. And so this is saying, hey, let's take ggplot. The data set I want to use is miles per gallon. Then let's add a layer corresponding to a geometry of points, where I map it between the aesthetics of X is displacement and Y is highway. And so that looks a little bit complicated, but the gist is that now it makes a plot using this data set. It knows that displacement's a column of miles per gallon. It knows that highway is a column of miles per gallon. And sort of this is stuff that you don't really have to change. But if you were to change variables you plot, you would just replace them in this X and Y call. So if I wanted a different column, I would do, like, all I would change is sort of the variable that's shown, not the actual AES or mapping or any of that stuff. And so this is nice because it's super flexible. But it also, that flexibility comes at a cost. It's a little bit non-intuitive, especially when you're getting going. So say I want to change this to now show, let's color the points by one of the columns called class. And so I can now do this. And again, all I changed was adding this color equals class. And so what it does is now it colors each point by the class column and then prints me a nice legend that shows me how each color corresponds to each column. And so now you can see maybe more associations in your data, where now maybe the SUVs and the pickups have more displacement and lower highway miles per gallon, and the compact cars and subcompacts have more miles per gallon but lower displacement. And sometimes it's kind of hard to see some of these plots depending on your screen resolution. So if you press the zoom button, it'll pop open in like a new browser, a new tab that lets you quickly see, that lets you sort of maybe just take a bigger look at it. And again, it kind of depends on your screen resolution. And again, if you resize with RStudio, it's nice. It'll sort of redo it for you. If I make it really small, it'll try to make the text big enough, like a consistent size, while making the plot panel smaller. One other thing you can change in this points is the shape of each point. And so now, instead of coloring things, I'll make things shaped by a different column, the drivetrain, or the type of drive. And so the four-wheel drive cars or all-wheel drive are circles. Triangles are now four-wheel drive, and squares are rear-wheel drive. And so again, it just shapes the points almost automatically. and provides you a nice legend that shows you how each shape corresponds to each type of data level. And so again, all I'm doing is I'm pressing Control Enter. You can change however you want and run it. Like that's why I sort of provided the R script for you, so that's totally customizable. You can also add comments as notes in the script as well. This will get saved in your RStudio Cloud session. You can also download this, as I'll show you at the very end, for how to take this back to your computer in case you want to try some of this on your own RStudio installation that's not on the cloud. And so to move on, though, now I again have this miles per gallon data set. I want G on points, same X and Y. Now I'm going to have shapes be the drivetrain and colors be the class. And that, again, gets created here, where now it creates, again, points and shapes. And again, it gives me legends for both, which is really nice, where it has, colors and points, same legend. It structures them nicely, does it for you automatically, very simple. You don't have to customize anything really up front. I mean, you might want to, but you don't have to necessarily. However, the most useful feature, I would say, of the ggplot2 structure plotting are these things called facets. And we saw that a little bit in the lab. That's where there were multi-panels. If you were to try to do that in BaseR, it's very complicated. But in ggplot2, all you really need to do is give it another argument or another layer called facet wrap. This tilde means as a function of an R. And so I'm making this plot as a function of class. And you can also give it additional information for how you want the layout to be in this multi-panel plot. So again, now I'm having highway, displacement, and I'm coloring by drivetrain instead of by class. I'm stratifying now by class. This is where zooming is much more useful. Here you'll see now that there's one panel for two-seater, one panel for compact, midsize, etc. And then the colors are preserved across all 7 panels. And they're all in the same X and Y axes, so it's easy to compare across different levels of your data. And again, doing something like this in BaseR is like many, many more lines of code. It will not look as nice as this, although you can do it functionally. And so this is like sort of the power of ggplot and its flexibility. There's a bunch of different geometries. Some of them are, again, more easily done in ggplot than BaseR. Smoothing is one of those. So say I want to have a smooth curve instead of a scatter plot. It uses this thing called LOS, which is like a local regression smoother, to add a smooth curve for each of my points and to add an error bar around them, which is shown in gray. It's important to note that I believe you should be able to do both of these things. So you can also add these things as layers. And so, for example, I could show the points. I can add a smooth curve with an error bar. And again, it shows you the flexibility of doing something with, a few extra lines of code. I believe you probably don't even need, this part of it. I guess you still do need that part of it. Sorry. Okay. Where are we? And so sometimes you can put the aesthetics up front. And then I believe, let me just copy this. Sometimes you can put this here. And then this there. And so if you want to dictate like X and Y in your ggplot call, you can maybe add layers a little bit more flexibly if you want to have multiple layers. So you don't need to write this mapping every time. And so this allows you to make, a complicated plot with sort of not that much code. You can make it where you can facet wrap here too. The error bars on the smooth curves are a little bit uninterpretable there. You get a bunch of warnings, but you can see that you can indeed get very complicated plots by just adding these layers on top of each other with ggplot2. If you are used to BaseR, if you've sort of had a little bit of R exposure but haven't really seen tidyverse, there's sort of this helper function called qplot for quick plot that uses more BaseR syntax, where X is displacement. I say X is displacement, Y is highway. The data set I'm using is called miles per gallon. I can give it colors, and I can throw in a facet directly in one line. And so this is very similar to the layered syntax I used above, where it, again, one line of code makes a very complicated plot that lets you just quickly visualize your data. Do people have questions on any of that? It was a lot of ggplot2, maybe not intuitive, but there's a ton of examples here in their website. And so there's like a million different types of layers. And so you can sort of see them all here. They sort of show a little bit of toy examples of like stuff next to them. You can make bar plots, contour plots, density plots, dot plots, histograms, polygons. You can add all sorts of aesthetics and scales and change the legend around. You can be very, very, very flexible, but sort of it just always involves like initiating some ggplot call, then adding layers to your plot. Again, you can see there's a ton of customization available. Just for exposure, there's like in base R, if you were to do similar things, this is the plot function. In base R, you extract columns with a $sign. So you would say miles per gallon, $sign displacement. Y is miles per gallon, $sign highway. So this is like the simplest possible thing you can make in R. It doesn't like the small margins on the plot. So it sort of makes this ugly plot that it's all white circles. It has bad labels. And so again, like using quick plot or something, it seems like it's a little bit easier. You can use this formula syntax to maybe make it a little better. So now it's saying highway, displacement, but again, everything's sort of just open circles, and coloring things is not as intuitive as the ggplot2 syntax. So I would definitely recommend ggplot2 to get started when you're trying to like learn how to do some plotting in R. Again, it's much more flexible. It can sort of make very simple plots very quickly, or very complicated plots very quickly. But again, sometimes in like if you Google for answers, like all of us do when we write R code, a lot of people just have like a plot call as like the solution to a question. So it's good to see some exposure to like sort of some base R syntax. But again, for like today's session and next week's session, we'll be mostly doing everything with this ggplot2 syntax or this tidyverse universe. So that's a little bit of plotting. We like starting with that because it's fun. You get to make pretty pictures very easily. But now we'll cover a little bit more of the infrastructure of sort of how to use R. And the main function in tidyverse there, or the main package in tidyverse is called dplyr. It's a relatively new grammar of data manipulation. I would say it's generally easier to learn than base R syntax. If you already know some base R, it might be a little bit less intuitive, but if you're a new user, I would highly recommend dplyr. And again, there's a ton of material on the R for Data Science website. Sort of just involves tidy data and data import, all cover how to use dplyr to clean up your data, or data transformation actually. So this data transformation chapter is how to use dplyr basically. And so this goes into way more detail than I'm going to go into today. It describes things much more detail than I'm going to go through today. And so on your own, you might want to work through this to just get a little bit more exposure to dplyr. It's also important to note in this book, there are questions. And so it gives you practice exercises. So exercises, you could, like, for example, you could read through that and say, find all flights that had an arrival delay of 2 or more hours. And so you can do all these things as practice to learn how to use dplyr better. And again, all this stuff I'm saying as resources I'm going to put on Blackboard. I just had some issues connected to it this morning. And we will send around sort of some practice exercises for you to get a little bit more exposure to R as well. And so here I'm going to work through some examples of using dplyr on that same data set, that miles per gallon data set. And so one thing you'll do a lot of is selecting columns. So maybe like somebody sent you some data that has like 1,000 columns. You really only care about 12 of them. You'd probably want to do some kind of data subsetting first to only look at the 12 you care about. And so the key function there in dplyr is select. And so the syntax is select, the name of the data set, then all the columns in the order you want to return them in. And so, for example, if I were to say select miles per gallon, and I want the manufacturer column, the model column and the displacement column, I would do this and then submit it and run it. And so here you'll note that it returns all 234 rows, just these 3 columns in the same order that they were in the full data set. This is the base R syntax. Again, it looks a little bit more complicated. You basically need to use these like brackets that say, hey, like, let's subset this. Let's take all rows because I'm not subsetting on the rows. I'm only selecting on the columns. You need to encapsulate things in quotes and collect them together. So like this seems a lot more intuitive maybe than this. And so, but they do the exact same thing. So if you already know some base R, that's what this would look like. But again, for this, I would recommend dplyr. You can also do things like select all but certain columns. So now I'm going to select everything minus drive. And so now it will return all 10 remaining columns, again, in the same order without this particular column provided. So sometimes it's easier to keep things by negation than to positively select for things. There are a bunch of helpers that come with tidy in the tidyverse called tidy select. And so, for example, there's a function called starts with. And so if I want to select columns that start with a C, this is how it looks. And you'll see that the tibble that gets returned, again, it's in the same order that was in the initial data set. Cylinder, city miles per gallon, and class. Sometimes you want to reorder columns. This is also a very common task. You want to say select miles per gallon. Let's put the class variable first and collect everything else in the sort of preserved order. You could do that. So now class becomes the first column, and then everything else gets shifted along. And so you'll do this a good bit. Again, mostly to subset down to specific columns that you care about for an analysis. Or maybe like when you read in data, a few columns are corrupted or represent like comments you left for yourself. You probably want to filter those out so you don't have to keep them in your data set. And so that's more like rearranging what you're looking at. But another important thing that you'll probably do even more often than that is filtering rows or removing observations or keeping observations. And the key function there is filter. And that has very similar syntax. You say filter, you give it the data set you want to subset, then you give it a column name, and then some kind of logical test for how you want to filter that. So basically, if I want to take the miles per gallon data set and only keep those rows where the class is a compact car, I would say filter miles per gallon, class equals, which in R means RU equal to, and then compact, which is encapsulated in quotes. So now when I run this, it spits out the results and says, hey, there's 47 rows that correspond to a compact, and here they are. So it's also important to know that everything I'm typing here is not actually saved in my R environment. I'm not assigning any of these to be some new R variable. I'm just sort of showing you how it's working. We'll come to assignment in a second. So basically, like R has no record of like, you can't do stats right now on just the compact cars because it's just sort of temporarily printed for you. Oops. You can also filter by numeric variables. And so now let's filter this where the city miles per gallon is more than 20. And so now it'll keep all rows, it'll keep all columns and just the rows where the city is more than 20, which correspond to 45 of them. And sometimes you want to filter on multiple columns. There's a few different ways you can do it. Take your data set. Let's say, hey, let's take it where the model is an A4 and the drivetrain is forward and the highway is more than 25. That's equivalent to chaining together these logical tests with an AND operator, which is the ampersand in R. And so this will tell you there are 7 cars that are Audi 4-wheel drive cars that have more than 25 miles per gallon. Another more liberal filter is an OR operator, which is the pipe, which is a shift forward slash, I guess. And that says, hey, are you an A4 or forward or 25? And this is a much more permissive filtering where now there's 121 because you just have to be any of these 3 things to be retained. Another popular type of filtering are maybe taking one variable and asking if its levels or if its variable, or if its levels or categories are in some specific subset of things. And so that the percent in percent operator is really useful. That's saying, is a manufacturer in Audi or in Subaru? If so, return it. Otherwise, remove it. And that's equivalent to just chaining together a bunch of these OR statements, which for 2 things, it's not that bad. But if you have 7 or 8 things, it gets a little bit tedious to type this out 7 or 8 times. And so you can say manufacturer in, and then print out, collect the 8 or 9 levels, and then just retain those. Again, in base R, it's a little bit different. Use the $ to grab columns. So I would say, hey, is the manufacturer column equal to Audi? Filter those rows while preserving all columns. Again, this maybe looks a little less intuitive. And so that's how you would filter rows. Again, it's a very quick overview of it. I would highly recommend reading through this R for data science to do it in more detail and also practice it, because it's important to practice it to get used to it. And sometimes you want to be able to filter both rows and columns, or filter rows and select columns in one shot. So say you could write something that looks like this. So let's run the select function around a filter function. So let's first filter to that model A4, then just select those columns that start with class, then everything else. And so this will do exactly that. Class comes first, everything else is there. It's only the 7 cars that are Audis. But this is sort of not nice to look at. You sort of have to remember to visually say, hey, filter comes first, it's in the inside. We're starting with the inside and working our way out. That's not intuitive to a lot of people. So there's this newer syntax called piping in this package called Magritter. And so this allows you to sort of stream temporary objects from one function to the next while not really retaining their output. And so it looks a little bit different. So you go, let's take the data set, miles per gallon, use percent, forward percent. If you're in RStudio, it's Control-Shift-M. It allows you to type these things really quickly. And so now I'm going to use the filter function. So first I'm going to filter to model A4. Note that you don't need to provide a data frame. You don't put miles per gallon here. It just comes in from the pipe directly. So if I were to do this, it just goes to the Audi A4. Then I'm piping into the select function. And then again, I don't need to put a data frame name. I just say, hey, let's collect the class variable and then everything else. Oops. And so now in one shot, you sort of just gone from the data to the filter, to the select, and then return the results. And so that's maybe like do this, then this, then this. It's probably a little bit more intuitive than this sort of like look inside and like work your way out in these like nested parentheses. And so it is important though that like order does matter here. Like if I were to try to take miles per gallon, say I want to select the Audis and return the class drivetrain to manufacturer, or say I want to return just the A4s, I try to run this, it's saying, hey, model's not found. That's because you're first selecting the columns class, drivetrain, and manufacturers. You're dropping the model column, and so it can no longer be used to filter rows because it doesn't exist in this data set. So it is important to note that the order does matter. You would have to reverse these like we just showed. But so if you're getting an error saying some variable's not found, maybe you're just using the select function before you're using the filter function. And again, like practicing is sort of the best way to learn this. We'll send out some example as like sort of a short, I guess, assignment. It's not really, I don't think for a grade or anything. It's just for you to practice the tools we've learned today. And so all the stuff I just showed was just sort of printing things. It wasn't retaining anything. And so the key way you do that in R is with the equal sign or the assignment operator. So if I were to say, let's take miles per gallon, pipe it to filter to Audi manufacturers, I'd say Audi equals that. And so now, and nothing gets printed. It doesn't show you anything. But if you look in your environment tab, now there's a data set called Audi, and there's 18 observations of 11 variables. You can also use this greater than hyphen to assign things. These are, for all intents and purposes, the exact same thing for this class and almost any other implementation of R. There's very, very few, very, very esoteric examples where you won't get the same thing, but it's not in this usage of it. And so you can either use the assignment like this, which again you might see on the internet somewhere, or you can use equals, which I prefer because it's less typing. And so now that you've added like a data set to your environment, you can sort of look at its structure. So there's this little play sign next to it. It just shows you a quick snapshot of the data, sort of what the first few observations are. In RStudio specifically, there's a function called view. If I type view Audi, it'll pop open a data, like an Excel-like data viewer on the right side in your source. And so it allows you to, especially when you're reading a large data set, you can sort of look around and sort of see what the data looks like. You can filter columns, you can search for rows, you can do all sorts of fun stuff. This sort of allows you to quickly like view your data visually. You can also filter by adding things up here, just to get a sense of what you read in. I don't always recommend using this, but again, if you're not used to some of the R syntax for doing these same tasks, this is a good way of, again, exploring your data as you get more comfortable with R. That does not work, though, with R Markdown. If you have a view call in your R Markdown document, you will not be able to knit the document because it's like an RStudio specific thing, not an R thing. I'm just going to show a few really quick summarizations that are useful. We're going to cover this much more in detail next week. One useful function is count. And so I'm going to take the miles per gallon data set. I'm going to pipe it to the count function to tabulate the number of cars for each manufacturer. And so now, and again, it comes back in alphabetical order saying there's 18 Audis, 19 Chevrolets, 37 Dodges, etc. This actually comes back as a tibble itself, so you could also like do something with this tibble. You can also count element multiple ways, so you can like chain together combinations of variables. Where now I'm saying, hey, in the year 1999, in a 4-cylinder, there's 45. In 1999, 6 cylinders, 45. 1999, 8 cylinders, 27, etc. So this allows you to just quickly look at how many of different combinations of variables there are in your data set. And again, this is way more useful on categorical or qualitative variables and not quantitative variables because there's way more levels of them. One other useful thing that has in tables that are not in data frames is this group by. And so you can make these grouped tables, which take a data set, groups by class, and in this case, and it's a column with your data set called class. If you actually just print it out, it looks really similar, except for there's an additional line of code, an additional line in the output called groups. Class, it says there's 7 of them. This is almost identical to the previous table. It just doesn't have this group notation. And so this is nice because it allows you to quickly summarize some column across groups. And so now if I were to say summarize, MPG group, let's make an output called city_average, where I take the mean, which is a function in R of the city miles per gallon. And so this allows me to return a table that's, I made this column called city average, and I populated it with the mean of whatever the city was in each of those 7 groups. So again, it's fairly advanced, not much code. You can even do it in one line of code where you take your miles per gallon, you group it by class, so you don't actually like preserve the grouping in the raw data, and then you just summarize with the exact same summarization command. And so these are very common tasks for exploratory data analysis, just making sure there's no weird SAMP outliers. Like for example, if one of them comes back as 996, you'd probably think that somebody put some random number in there somewhere. So you'll be able to like go in and investigate and do some data cleaning next class we'll talk about. And so that's just sort of some very basic summarization. You can be very, very flexible with sort of how you summarize, but this is just some very basic things. So all of that I just covered was just sort of like how you do things when you already have data in R. But in practice, the first thing you'll do is read your own data into R. And there's a bunch of tools for doing that. And so reading in and importing your data is important and usually the starting point for any analysis. In the tidyverse universe, there's a package called reader, but there's also a series of base R functions like read.csv. And so, for example, what you might want to do is the most important thing when reading in files is knowing where they are in your computer and then knowing where you are in R. And so, for example, I have a file in the basic R folder called supplementary table 2, schizophrenia gene full. I'm trying to read it into my RStudio session, but it's saying, hey, that file's not in the current working directory, where my current working directory is cloud project RStudio. And then you realize that you're in the wrong place. So then you can do a few different things. Under more in the files viewer, you can go to the folder you want to be in and say, hey, let's set this as the working directory. That's some drop-down support that is provided by RStudio. You can mimic that by just typing this code, set WD, and just tell it what path you want to be in. This will now allow me to read in this data set. And so when I run read_CSV and it finds the file, it tells you it's parsing it with certain column specifications. And it sometimes gives you some warnings saying I'm filling in some column names. It's important to note that, especially with like reading in long files, if you press quote and press tab, this is that tab completion. It shows you all the files in my working directory. I can just quickly go to this one and press enter, and it fills it in for me without having to type 30 characters. Also, when getting started, you maybe aren't super comfortable using some of this this code. So in the file dropdown, there's a import datasets tab. You can say from text in reader, and that pops open this little GUI table. And so I can go browse on my computer, in this case on my RStudio Cloud session. I can find that CSV. It'll give you a data preview. And so some important things here are, once you give it the path, it populates a preview. You just want to make sure, you'll want to call it something differently. You'll want to call it res, maybe, like to mimic what I have in the code. Sometimes there's metadata in the first few rows. You might want to skip some rows if there's a bunch of comments that somebody left, like explaining what the columns represent. This one's important. This is if the first rows correspond to column names or headers. That's usually the case. Sometimes there's just blank rows interspersed in there. This will remove those. Sometimes there's also trailing or leading white space in like a character string. This will trim that. This also asks if you want to pop it open in my RStudio session, which is just that view tab. And then some other things like what it's delimited by, what's the comment variable, what's the NA variable. There are a few things here too where you can tell it, it'll try to guess what the type of data is. So like it's thinking symbols, gene symbols are character strings. These entree gene IDs are double, which are integer, which are numeric values, etc. So what's nice is like it's showing you how the code is changing when I unselect or select things. So maybe I think it's semicolon delimited. The preview is like, no, you're probably not semicolon delimited. This is gonna look crazy. So you can go back, but you can see how the code changes correspondingly, and then you can press import, and that will spit out the code required to read it in yourself. And so then you can go to your history tab. You can like find the code you just ran, and you can copy it back to your source. And so you can try it interactively, then save it for future reference by copying it to your source. And so now that we've read this in, and again, this is super flexible. You can read in all types of file formats. But let's just say we read this in. It's differential expression results from a schizophrenia project from 2 brain regions, the hippocampus and the dorsolateral prefrontal cortex. We can filter on expression level and sort of drop a column that's sort of confusing here. So we'll select everything but the gen code transfer column, and we'll filter to select just the DLPFC. And so I'm going to assign this to be a new data frame called res_DLPFC. And here you'll see that there are now 2,400,652 rows. Each one's corresponding to a gene. And now we can make a volcano plot with ggplot, which is a popular genomics data visualization. So I'm going to say the data frame is res_DLPFC. The G on point corresponds to mapping. X is the log2 fold change. Y is the negative log10 p-value. And I'm going to code the points by whether they were false discovery rate, adjusted p-values less than 5%. So now it makes a volcano plot with log fold change on the x-axis, negative log10 p-value, and you're green if you're significant, and you're red if you're not. And so that's just some genomics examples for how to read in some data and then plot it. And so if people have questions, that's sort of a lot to cover in 1 hour. Is everybody totally lost? Who's totally lost? You can be totally honest. Okay, a few people. So I'm going to send out some resources that can help you get maybe a little bit up and running. This definitely is like learning a foreign language. It takes a lot of practice to get good at it. I've been using R for like 12 years now. Matt has learned, and Grant have both been using it for about 2 years now. It's not a little bit longer. So this is one of those things that just requires some practice. I would also say it's also a lot easier to learn if you like have a data set you really want to analyze. It's sort of hard to use some of these toy examples because you maybe can't relate to them. But I think that will provide some additional help for doing some of this. And that will allow you to maybe learn it a little bit better. I think it would, especially if you're a little bit uncomfortable today, to work through some of the examples because we're sort of building on what we learned today, next week and then the following week. Although then it resets totally to Python. So if you don't like R and you like Python, then you might be good after a few weeks. It's sort of just personal preference between those two popular programs. And so do people have questions about what I covered today? Nope. If you guys have questions, email me. I'm going to add a list of resources to the Blackboard account. And then an assignment will circulate around that's just for extra practice on this DLPFC and hippocampus results section. And with that, I guess we'll end a few minutes early to let you guys get some lunch. Thanks.